In this video, to continue my series on quantum computing, I'll be discussing the Z-gate. So if we write our basis states of 0 and 1 in vector notation as here, our Z-gate can be written as a matrix as such. The function of a Z-gate is that it acts on a qubit of value 0 and it will return that same qubit in 0. Meanwhile, if it acts on a qubit of value 1, it will add a negative sign to that qubit and in a way add a phase to it. So as you can see from this, the Z-gate doesn't really have a classical analog in that it either acts as the identity or just adds a phase. Conceptually, you'll also see how the Z-gate, if it acts twice on a qubit, will always act as the identity and just return that qubit. If the qubit started in a value of 0, the Z-gate won't act at all, and thus you could see how you'll get 0 back. Meanwhile, if the qubit started in a value of 1, you'll get 2 negatives that will cancel out to bring a positive. Mathematically, though, you can also see how, using matrix multiplication, z squared is just the identity. So that covers some basics of what the Z-gate does, and in future videos I'll get a little bit more into the more complex processes that you can use it for. Thank you for watching, and if you have any questions or suggestions, please comment below.